Alright, so now we're on 5 part C. And this problem is the integral of x plus 3 over x squared plus 4x plus 7 dx. So this problem is extremely similar to the question in part B. So if you haven't watched the part B video yet, I suggest you do, because these two problems are almost the same. They're just really tricky for students to see, which is why we put 2 of them on this review. So what you want to notice, just like in the previous one, your denominator here does not factor. So this is actually not going to really be a partial fractions problem. Instead, you're going to have to complete the square on the bottom. So what we get when we do that for this to be a perfect square with a 4x, it would need to be x squared plus 4x plus 4. So we can say that this is x squared plus 4x plus 4 plus 3, because that gives us the same thing as plus 7, except this part of it now is a perfect square. So this integral is x plus 3 over x plus 2 squared plus 3. You can see here now, this is not factorable in any sense. So this is not going to be a partial fractions problem. Instead, we're going to need to do this by splitting up these two. So we're going to have the integrals x over x plus 2 squared plus 3 plus the integral of 3 over x plus 2 squared plus 3. Okay, so what we need though is something in the numerator here that is the derivative of the bottom. If that's the case, we have a natural log. The derivative of the bottom here is 2 times x plus 2. Remember that a constant multiple can always be taken out of the integral, so that's not important here. The part of the derivative that would have to cancel out is x plus 2. Well, we can do that by just adding 2 here. If we're going to add 2 though, we have to subtract 2. However, if we're going to subtract 2, we want to do it from this one because that's the one that already just has a number. They're the same denominator. So if you had put a minus 2 here, you would just split that fraction off, but then you would end up having to combine it with that one anyway. So you can just put the minus 2 here. Again, like how I showed in the previous problem, this is like putting plus 2 minus 2 here. And I just wrote them in a different order and put them how it needs to be to make this problem as easy as possible. So this is just a matter of u substitution with u being x plus 2. I'm going to skip a couple steps in the work here just because that's an integral that you've done 100 different times. The derivative of x plus 2 is just 1, so obviously that tells you you don't really have to do substitution. It's just going to stay the same. However, the derivative of the bottom is 2 times x plus 2, so you're going to get a 2 to come out on the denominator. This ends up being 1/2 ln of x plus 2 squared plus 3. Alright, so this 1/2 just comes from the fact that the actual derivative of the bottom is 2 times x plus 2. On the top, we just had x plus 2. A way a lot of students like seeing that is, if I put a 2 here, now the top is exactly the derivative of the bottom, so I can just say it's ln. But if I put a 2 here, I have to divide by 2 out front, so that I didn't change anything. So that we get that here. This is just 1 over x plus 2 squared plus 3. And that is just an arctan. Instead of x, we have x plus 2. That doesn't change anything because its derivative is still 1. But our a, or our a squared in this case, is 3. So remember that you have to divide by the square root of that when you're doing the arctans. So this is going to be 1 over square root of 3 arctan x plus 2 over square root of 3. Remember that that square root of a, or that a, sorry, which in this case ends up being square root of 3, has to be divided in front of the arctan and inside whatever the variable part is. And then we have plus c. Just like that. So when you complete the square, expect the problems to be of this format.